Good morning. My name is Kyle Houchins. I'm a technical trainer for McNeil, and this is Getting Started Rhino for Windows. If you haven't taken one of my Getting Started sessions before, they work a little different than a lot of software demos that you may have seen over the years. This is an interactive session. Interactive in terms of hitting the chat, asking questions. You're more than welcome to, if I do something and you look at it and you go, whoa, what is that? Hit the chat. I'll back up a little bit and we'll talk a little bit about it and go from there. Don't try and keep up with me. Don't try and model with me because we're going to move pretty fast. Just take some notes, and then this is all going to be recorded on YouTube. I did put the link for that in the chat. And we will dig into this little clamp here, and we're going to talk a little bit about strategy and how to approach a model like this. So buckle up, and let's go ahead and jump in. The way that I usually do these is either the night before or the morning of. I do a scrubby little sketch of something, and then I put it away. I don't look at it, and I don't practice this, and I don't, prepare in any way. I just do the sketch, put it away, and then I the next time I look at it is when it's showtime and we're ready to go. And the reason that I do that is because I want to simulate for myself the thing that you face when somebody walks into your office and hands you a sketch and says, build this. And you have to figure it out along the way and go from there. So the first thing I always do is bring the sketch into Rhino, and the way that we do that is with the picture command. And if we just run picture, we find it on our desktop, we click and drag it into the scene. In this case, everybody always beats on me because I don't scale these drawings. So the way to scale this is I just pick a point in space, I decide how long this thing is going to be. In this case, it's about 10 inches, and then we run the scale command. I already did this. Shh. And we draw, this, we change the scale of this to match what we want to do. All right, I already did that. So this thing is actually scaled to about 10 inches. And that's what we'll work on from here. So I also take the image and I throw it on a layer. And we just do that by making a layer, renaming a layer, change object layer, and then the last thing I do is go to the Materials tab, and if the Materials tab isn't loaded for you, right-click on any other tab, bring up the Materials, and click on the material that's there, and we're just going to drag the transparency up a little bit to fade it out. And then the last thing I do is I actually like to move this out of the modeling volume. Wherever the model is going to be, I try and move the image out of that. And the reason that I do that is if we were to build a model of some sort and then go into shaded mode, my drawing gets eaten by the model. So I like to take this and stick it back here in space so that I can actually see what's going on, and then in front view it's still, visible and all that kind of stuff. So let's take this, and that's all set up correctly. We're going to go back to the default layer, and I'm going to lock this layer so now it's stuck there, and we can start working. So the first thing that I always do when I am handed a sketch like this is try and look at it in terms of Rhino tools. And I don't know if you can see some of the notes I made in here. Like these pockets, these are just push-pull all day. These shapes are kind of just draw, curve, and extrude. This is draw, curve, and extrude. This is draw, curve, and extrude. And to some extent, this entire model is draw, curve, and extrude, and then do stuff to it. The one detail down here is the end of this thing is actually rounded instead of square. So this will provide us with a little bit of a modeling challenge here, and then we'll worry about, fit ups and all that kind of stuff. So to get started, we're going to, and this is actually a fairly symmetrical piece side to side. So we're going to build one and then flip it and then add the details that make each one of these, asymmetrical. This one obviously has a thing here, and it's got a little slot there and a thing here and a thing there, and we'll figure all that out as we go. So let's jump in and do the right side. We'll do this one over here first, and basically it all starts from a curve, right? We're going to overbuild our curves. We're going to make our corners with 3 points because you have obviously watched the Rule of 3 video and you know everything about making corners using only 3 points. And if you haven't, you're going to YouTube right now, our Rhino page, and you're looking for the Rule of 3 video, and you're bookmarking it for later, and you're going to watch that and learn everything there is to know about making nice, simple corners in NURBS instead of machine gunning points into a corner and making a big, giant mess. And if you're not, then we're going to do a 2-second talk about rule of 3. Rule of 3 is 3 points to make a corner. Okay? That's as simple as it gets. And this is curves, surfaces, and sub-Ds. 3 points to make a corner. If you need to make the corner tighter, you take this and you move them closer. If you need to make it softer, you move them farther apart. All right? That's the basics. You don't do this. No. Don't do that. This makes everyone sad, especially you, because you're going to have to deal with the surface that makes later. So we're going to make nice, simple curves. We're going to use 3 points for each section of the curve that has a transition in it. And we're going to be fussy little designers, and we're going to tweak that just a little bit with nudge keys. And if you don't know where the nudge keys are, they are in Tools, Options, Modeling Aids, Nudge, right here. I have mine set to use the arrow keys instead of alt arrow keys because I like using alt to disable and enable O-snaps. You can change the size of the snap. Just the arrow is this, control plus arrow is that, shift plus arrow is that. Gives you a nice little control, and then you can decide, the directions, whether it's control polygon, UVN, C-planes, whatever. I usually have it set to C-planes because that's the easiest way to do it. All right, so the next thing I'm going to do is I'm actually going to copy and paste this curve because I already drew it and I'm lazy and I don't want to redraw it, so I'm going to stick it down here, and then I'm going to turn these points on. And I'm going to just modify this guy because it's similar to my other curve, and the point structure matches the other curve, and it's easy to drag this thing into shape instead of having to fuss around and make a new curve. And the nice thing about this is I know that if I were to loft this curve and this curve, the parameterization between the first curve and the second curve is going to match well enough that a lofted surface is going to kind of behave itself. Oftentimes when you loft something, if you loft a curve that has, like, say 10 points and you loft it to another curve that has 50 points, the resulting loft is going to end up being kind of hot garbage, and we don't really want that. So I think in a lot of cases when I'm trying to do something where I may, and I don't know whether I'm going to loft this or not, probably not, truth be told, but a lot of times what I'll do is I will steal one curve and then just, drag it into shape for the other curves that I need. Some people don't do that. I do that. Use the technique that works for you. And we're going to just draw that out. The main shape that we're going to focus on is the inner shape here. And the reason for that is this part out here is going to be an addition. This is kind of a soft transition from the front to the back. The hard shape is actually this inside line, so we're going to kind of focus on that for the time being. And I'm going to just draw a curve there. We're overdrawing all our curves because we're going to trim them back in a bit. And that rule of 3, the thing that I want you to pay attention to here is if we look at this curve, there is a curve here, right? From this point to this point, there's a shape there. We only need 1 point to control what that shape for that part of the curve is. Turn the points on. From this point to this point, there's a curve. I only need 3 points to define what that shape is, and I can edit this shape to get the shape that I want and see how easy this is to understand. Now, let's look at the further down the line. This next set of 3, there is a shape that goes from here to here. I might be able to get away with getting rid of a point. And I can try that and notice that my shape now changed a little bit, but I may be able to get there by pulling this back. I've got this part of the curve is good, this part of the curve is good, this part of the curve is not, but if I pull up here, you'll notice that I can get there. And that extra point that I drew was unnecessary. So I want you to get in the habit of looking at your curves and analyzing them by section and saying, this is a curve, and then it inflects, right? You can see because the point changes from this side of the line to this side of the line, so we know it inflects. So there is going to be a curvature change there, right? So we're going to go, this is one part of the curve, right? And there's only 3 points in that part of the curve. This is the next part of the curve, and there's only 3 points in there. And then this is another part of the curve, and there's only 3 points there. That way I only have to worry about this one, and this one as far as being able to control the shape of what's going on here, right? So depending on what happens with this is going to affect what, this curve is doing down here. And then I can decide where it's going to end like that. All right. And we'll fuss this, we'll look at it just critically because we're going to not trust the drawing because the drawing is trash because I did it quickly and didn't pay a whole lot of attention to it. So we're gonna critically evaluate these curves and make sure that these shapes are all doing what we want them to do. And there's something about this one that doesn't feel quite right in relationship to this curve. And maybe it's a matter of this needs to come in a little bit. We always want our family of shapes to kind of work together. There should be kind of a thick, thin, there should be, a dynamic quality to the curve, and, take the time to do the work on your curves because that's going to make the difference in your model later. And I always like to say the goal of this is we're not CAD monkeys, right? We're not just copying a drawing. We're designers and we're artists and we're trying to make designs and art. And we want to make sure that the stuff that we're making actually, looks good. All that kind of stuff. It's crazy, I know. All right, I'm going to clip this kind of just like that. And so I've got all my curves, and I'm going to just cheat and use a curve Boolean, and I'm going to delete all my inputs, and I'm going to click inside here, and it's going to just trim all that stuff out at once and give me this closed shape. Now, I could at this point take the time to draft out the rest, draft out these pockets and stuff like that. But I think what I'm going to do is use Inset later and let that work get done for me by that tool. So in the meantime, let's just take this thing and, for lack of any other better idea, let's just bust a shape out of this thing. And it's about, we'll call it that thick, right? And we can try and figure out how thick that is. Probably, a lot of people would like to put a dimension on that. 0.79. Maybe we do this and we say, let's extrude it 0.75 so we know it's a specific distance, right? So that way we can put a dimension on that, and that way all the people who get on YouTube and yell at me for not measuring things can just calm right down. So we've got our basic shape here, and we have to think about kind of how we want to proceed with a couple of areas. One would be this bottom area down here, and if we look at our drawing, I drew it all the way to the end. And maybe that was the right idea, maybe it wasn't. Maybe the right idea would be to now disassemble this a little bit. So now it's exploded into its basic surfaces. And maybe what we should do is split by edge, split by isocurve, and pull up somewhere kind of right in here that feels where that transition should happen. And I'm going to use O-snap to snap another one back there. This surface now becomes something that we don't need anymore. And maybe what I want to do is run a blend surface between this surface and this surface. And let that be tangent. We don't need to get crazy. And maybe we'll pull that in just a little bit. And we'll say okay. And then we can use this surface to trim this surface. And it doesn't quite extend out as far as we need to get that surface. So what we're going to do is turn on the points. I'm going to grab all of these points except for these two. And I'm going to just move these a little bit like that. So it intersects. Okay. The surfaces that Rhino gives you are merely a starting point, because once you access the points and start sculpting on these surfaces, then the whole world opens up as far as shapes that you can make. So I want you to get in the habit of saying, hey, Rhino, thanks for the early, result here, but I'm going to jump into the points and take it from here. So the way that we can look at this thing, and we can kind of think about, like, are you the kind of person that likes to knock off the hard stuff first and then cruise, home with the easy stuff? Or do you like to pick at the easy stuff first and, procrastinate on the hard stuff, hoping that it'll go away? That never works for me, so I tend to just jump into the hard thing. And the hard thing on this is going to be this section right here. And the reality is, it's not really that hard. If I just take this surface and delete it, and I were to simply blend from this surface to this surface, you can see that it generates something, right? And if I look at my curve, let's just let that run. That's not the right solution, but you can see that very easily, with this concept in mind of blending this surface and this surface, we can get a rounded thing, right? So let's take that one step further, and let's define what this shape is supposed to be doing. And we're going to do that just by snapping to an edge, and that's our first point. This is our second point. This is our third point. The curve's going to inflect. So this is now becomes our first point for the next section. This is our second point. And then right here at the bottom is going to be our third point. Okay? Look how close we get to start with. And so now all we need to do is just a little bit of fussing, and I can do that with the nudge keys, which is a really lovely way of point editing. And we end up with something that's pretty darn close. Okay? Nice clean curve. It's not flat because sometimes the world is a cruel and unusual place. The reason it's not flat is because I snapped to this corner first, and then I snapped to the center down here. So Rhino said, okay, I'm gonna stick this over here, but you're not gonna like it. Let's fix that. So I'm gonna double click on this C-plane waffle right here, which breaks the gumball loose. And using O-snap, I'm gonna snap it to the center of this. Actually, I'm going to do this off the center of the gumball. And I'm going to snap it right there. And now that it's snapped to this point, this becomes our pivot point. This becomes the center of the world for this object. And if I just scale this to 0, it snaps the entire curve to be flat with that plane, which is actually what I wanted in the first place. So to build a surface off of this, what I'm going to do is I'm actually going to build a proxy surface that goes in this direction, because that now gives me something to reference tangent to. Okay? One of the most important things about tangency, and I'm going to break away from the model for just a second and talk about this, is to understand points. And if we take this curve and I mirror it, okay, and I look at the points for both of these, this is your welcome to continuity TED Talk here. All right. So positional continuity, or G0, is considered these 2 points right here from this curve and this curve, right? If I move these apart, it's got a point there and there. In this situation, there's 2 points there, right? Up here, 2 points, but they're coincident. They're on top of each other. That's G0. That means the curves are touching. That is positional continuity. That is G0. You hear it referred to as a couple of different ways. The tangent, or G1, which it's also referred to, means this point, and this point. Not only are these 2 points touching, but this point and this point are all in a straight line. So this is tangent, this is tangent, this is tangent, that's tangent. As long as you can draw a straight line through the G0 and the G1 points and they all line up, this curve is going to be tangent. And if you don't believe me, we can run Gcon and we can go here and here. Curves are G1. See, told you. All right. This is the easiest part of continuity to understand. Curvature starts getting, it starts melting your head when you start getting into that. And I was talking to Dr. Lear, our lead math guy, about how to explain continuity in a way that's easily understandable. And I walked away after I got done sobbing from the calculus lecture he gave me, because I went to art school. I'm not a programmer, right? He's mad. People start talking math, and I just hear beep, boop, beep, boop, beep. So curvature is much more complicated to understand, but tangency is very, very simple. You've got 3 points all lined up, okay? As long as you can draw a straight line through them, they're lined up. And we'll talk more about that as we go forward. But the reason that I want you to understand that is if I have a straight line, what does a straight line have? A straight line has, say it with me, class, 2 points. That means that these 2 points give us an opportunity to match another curve to this. Doesn't matter what it does down here, right? This can be blah, blah, blah. It doesn't matter. But what happens is when I turn the points on for both of these curves, what happens here? This is the point of the straight line. These are the points for the beginning of this curve. And what happens if I Gcon these? These curves are G1. These curves are also G1, also G1, also. It doesn't matter what you do with it as long as they're in a straight line, they are G1. Now, what does that have to do with anything that we're doing with this scrubby little clamp drawing? Well, if you take a curve and you extrude it and you turn the points onto the surface, what do you get? You get 2 points. And it doesn't matter how long the surface is. As long as it's extruded in a straight line, you're going to get 2 points. This is a degree 1 surface in this direction, which means it only has 2 points. If it was a degree 3, it would have 4 points. Doesn't really matter as long as the first 2 points in the surface are lined up. Okay? We could do the same thing here. If we change degree to 3 and we had 4 points in this surface, if I took these 2 points here and I bent them out like this, okay, I could still do the same thing that I'm going to do because these first 2 points are lined up and I could match tangent to that. So this is a proxy surface. I'm going to leave this at 2 points for now. This is a proxy surface, and the idea behind this is we are going to blend from this object to this object. And it's going to give us a hellacious mass because it's coming to a point down here. And that is causing all sorts of trouble with this blend. So what we have to do is think about this in a little bit different way. If I move the start endpoint up to here, it's going to give me a little different result. And if I move the start endpoint, let's go kind of somewhere, I don't know, just someplace comfortable down in here. And then I fiddle these settings, you'll see that this surface then starts to behave. Now, what do you notice about this? This has 2 points in this direction, which means that this point, and whatever is this next point in this surface down here are lined up. And I have a slider, which I can change that tangency ratio, right? We can be real close or we can be real far away. In this case, I want this to be pretty close, like that. In fact, I may even set number 1 to position, because I actually kind of want a little bit of a sharp break right there. But I do want this to be nice and soft going in to the center. And so I might leave that set to 1. I can play with this and change the bias on it and get something kind of Let's just call that good there. Now, the cool thing about this, I've established a center line, which means if I take this thing and I mirror it about that center line, what's going to happen when I turn the points on for these two surfaces? Let me flip these because they're inside out. If I turn the points on, what's going to happen? Look at that. All lined up, which means that these two surfaces are tangent to each other. Now, cool trick. Let's back up a little bit. If you want your tangency to be different than directly straight across the center line, all you got to do is change the shape of your proxy surface. Now this tangency is going to be calculated at an angle, and you can do all sorts of fun stuff with that. In this case, I don't want it to be. I want it to be right across the center line, so we're going to leave it like that. But this is a very common thing for establishing centerline tangency, and that keeps you from getting what we like to refer to as a butt, which means that it's either going to have a little fin where it's got a little pokey part in the middle, or it's going to have a butt where it sinks down in the middle and it looks like a little booty. We don't want either one of those. So I'm going to join this, and then I'm going to flip it. And you can see that not only are we following the shape of our handle, but we have a nice tangent starting point to begin with. And on this side, we have essentially a four-sided surface. We've got 1, 2, 3, 4. And if we join this all back up, and we look at the show edges report, this is the show edges command, and we're looking at naked edges, you can see that we've got one edge here, one edge here, one edge here, and one edge here. Now, this limits our choices as far as what we're going to be able to do with surfacing tools, because we can't use an edge surf, right? We can't use this one because it's going to ask for 2, 3, or 4 curves. And if I go 1, 2, 3, 4, it gives me this result, which is not what I want. There are some tools, however, that allow you to chain edges, and one of those is Sweep 2. And if we use Sweep 2 with chain edges, and we auto-chain them, I can have this be one edge, this be another edge, and this is a gen curve, and that's a gen curve. And that gives us a really nice result. Not only does it give us a nice result, but we've got some continuity tools in here. So on A, we're going to change that to tangency because we want that to blend in nicely. B, we're going to leave it position. That's just going to touch there, right? So that's G0. And if we were to look at the points on this surface, we could see exactly how our tangency is happening, right? This point and this point are tangent with this point and whatever the next point is down here. Okay? We can mess around with this and decide, how we want to affect the tangency on this, but I think I'm going to just let this run the way Rhino gave it to me because I'm pretty happy with that at the time being. And I'm just going to flip this. I've got my backsides, the back-facing surfaces a different color so I can see them. And if we look at this, we can see that this actually not bad, right? That actually looks pretty okay. And if we throw a material on this, and let's make this a plastic, and let's do some kind of dun 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 clink clink kind of color. And throw this into rendered mode, and we hide this. We can see that that's pretty not so bad result. So I'm going to call that good. So let's go back into shaded mode and figure out how to deal with the end down here. And there's a little difference in how this is going to work down here, and we may actually need to bite into this surface a little bit. So let's just see what happens. And the cheat is if we chain edges using blend surf, and I chain this and I go to that, it's gonna give me a result. And if I go tangent, you can see that it's tangent on 1. 2, actually, I'm going to switch that to position and see how that goes. And actually, that looks surprisingly good. So I think I'm going to let that, roll. I think that actually is going to work out well. I was expecting that to be more complicated, but I'll take it. So this gives us a pretty okay result in there, right? I think I'm going to call that good. So let's look at the more complicated parts of this, or the less complicated parts, since we knocked off the complicated part. And those are, these little spinny bits out here, and we're going to do those I'm just going to draft those out with a circle and a square, and I'm going to do this from the center so that I can get this kind of lined up so that it's equal top and bottom. And I'm going to curve Boolean these, click outside in this case, and it's going to combine everything. I love curve Boolean, by the way. If you guys don't use curve Boolean, it's pretty rad. And then I'm going to fillet the corners on this curve just because it's going to get me a long way to start with. So 0.08 is probably too far. Let's go 0.04. That's probably still too far. So let's do something like that. That's probably fine. And so now this gave me and I need to remember this value that I set, 0.02. And the reason for that is if I try to put a 0.02 fillet on this when I extrude it, I'm going to just extrude this thing. I'm going to set this to the center. If you don't have Snappy Gumball turned on, by the way, right-click on this. There is a Snappy and a Smooth setting. I always run my Gumball Snappy because it now respects O-snaps, and then I also run my O-snaps disabled, and I use the Alt key. So right now I can drag this around and it doesn't snap to anything, but if I hold down Alt, you can see that it snaps to the middle of that, and that allows me to be able to tell that that is dead centered. And so now I'm going to grab this and I'm going to drag the extrude dot, hold down Shift, and I'm going to create a little piece of geometry that sticks out about that far. Maybe that's too big. Maybe we'll bring this in just a little bit. And the internet's going crazy because I'm not measuring. That's me. I'm a rebel. All right, so the next thing we want to do is knock the corners off of this. And remember how I said we needed to remember that value that we threw in here, this 0.02? That's important to remember because if I go to fillet edges and I chain these edges and I pick this and I set this to 0.02, it is most likely going to fail. And everybody then jumps on the internet and screams about how terrible Rhino is. The reason for that is this is a 0.02 radius fillet to start with, which means if I'm going to do this, my next radius has to be smaller. So I'm going to grab all of these. Remarkably, it works. Now, if I needed this to be 0.02 everywhere, if I wanted all of these to match and all be 0.02, don't fillet the corners on the original curve. Leave them sharp, extrude it sharp, and then fillet all the corners at the same time. If you fillet them all at the same time, you can do them all at 0.02 or 4 or whatever you want to do. What you can't do is fillet something at 0.02 and then go back and put a 0.02 on top of it. Each subsequent fillet that you apply on a Rhino model has to be slightly smaller than the other one in order to be able to fit in the radius that the original fillet created. Okay? There's math people out there that can explain exactly why that is. I'm not one of them. So the next thing that we want to do is we want to determine kind of where the snap for this thing is going to be. And if we go to the top view and I'm going to isolate, I'm going to just take a square and I'm going to snap this to the midpoint and I'm going to just hog a chunk of this out. And we're going to say that is about where our center is going to be. There's a little cutter on the gumball. We're just going to go wing, and it's going to just cut a section out of there. I'm going to save that curve because now what I want to do, actually I don't even need to do that. Check this out. So now what I'm going to do is I'm going to copy paste this, and I'm going to scale my copy in just a hair, and then I'm going to scale it just a tiny bit bigger, like that. And then I'm going to take my copy, if I can remember which one it is. I'm going to subtract the copy, the bigger one, from this. And that should give me the spot for that to live, and it does. And it looks like my plan may have been flawed. All right, so I'm going to set the gumball to the center of this, and I'm going to just scale that down just a tiny bit. That way I've got some clearance. And then let's look at the top and make sure that I've got my clearance still. And then I'm going to pull this out just a little bit. And then this is going to need something for it to pivot on. So we're just going to grab a sphere. Going to snap that to the center. And we're going to call that, I don't know, something like that. We'll call that pivoty. And then we're going to mirror this to here. And then I'm going to copy that for the time being. Boolean all this together. I'm going to bring this part back, isolate it, paste the one that I copied, and I'm going to make this just a hair bigger. I'm going to mirror that one, and then I'm going to Boolean subtract from there. That gives me the little dimples that thing fits on. And then the last thing I need to do in order to allow this to be able to actually spin up and down is I need to knock these corners off. So I'm going to go from the center of here, and I'm going to knock both of these off. Let's see. I tell you what. Let's just, we don't need to get super crazy with this. Let's just knock the edges off using fillet. And we're going to make this bigger. Something like, we'll call it something like that. I always try to use a round number. I had a machinist once yell at me because I was using like 0.1843. And he's like, why are you doing that? I don't have a 0.1843 cutter. It's like, use normal sizes. So in this case, 0.275 would be a normal cutter that they would have, whereas 0.283416 they would not have. So now we should be able to spin that thing a little bit up and down and get some clearance. All right, now we can talk about making this thing more interesting, but let's get these pieces. How are we doing for time? Yeah, we're doing all right. So what I want to do now is, and we'll do this in shaded mode so you can see it. There's a command called Inset that was new for 8, and what we're going to do is pick this face, and we're going to use through point, and we are not going to split because we want to create a curve. And if you look, what it does is it actually draws a curve on the surface that's inset by whatever value you're choosing here, right? So we're going to do that. And that is going to create a curve on the surface. And that's cool because I'll show you in a minute. So now what I'm going to do is I'm going to draw a curve from here to here. And I'm actually going to use a trick also in V8, which is auto C-plane. And I'm going to Control Shift click this face. And what it's going to do is it's going to create a C-plane that is right on that surface. And if I go to the front view, when I draw my curve, it should be on that C-plane. So I'm going to draw that curve. I'm going to draw this curve. And I'm going to draw that curve. And then it looks like my label space or whatever that is there is a little different. So I'm going to snap to this guy and then kind of pull out like that. Okay. So if I go back to perspective view, those curves should all be drawn on that surface because we snapped that C-plane there. Now what we can do is we can use push-pull, and I can pick this surface and this surface, and I can just push those in a little bit. And that is just a delightful feature that is in V8. Okay. Now, if I was being clever, I would have looked to see how deep that part is to start with. And it looks like I got away with it. It looks like there's plenty of material in there to be able to work with. So I'm going to leave this alone for the time being because these are actually scalloped out from the back. But what I want to do is I want to get the other piece and I want to mirror that so that I can start to figure out how these two things fit together. And the way that they fit together is half of this one gets chewed off and half of this one gets chewed off. And so what I need to do actually is take this one and figure out where they intersect and then, go from there. So let's mirror this to there, and then we need to figure out like what they look like when it's closed. And so if I take this thing and I rotate it, let's rotate it between these 2 points. And let's go from here to there. And then let's rotate this guy from the center of this. And let's rotate him. Got auto C-plane on. I was like, what in the world is going on there? So let's go to front view. And then let's rotate this. Auto C-plane is one of those things that's like super useful, and then every so once in a while it is a gigantic pain. So I end up turning it on and off quite frequently. So let's take this and let's mirror this again. So that's touching more or less. We'll figure out that we'll call that good enough. And then we have to say, okay, this thing is now, that's the center point. So if I take these two guys and I intersect them, and then I look at this guy and this, I should be able to kind of figure out like where this thing needs to get chewed off. And it looks like this is kind of the line where it needs to get split in half. And so if I take this and I say, let's dig out, I don't know what our range of motion is going to be. Maybe we need to take another one and figure it out, make another copy of this, and then figure out what the end of it is. But I don't know, that seems complicated. It's complicated for a demo this early in the morning. Let's just hack half of it off and call it a day. All right. You guys are gonna be like, oh, this is the dumbest demo ever if they don't figure this out. So, all right, so let's take another one of these and let's copy paste, and then let's rotate between here and here, And then let's rotate that copy and say it's got to go like that far. Like that. And then let's intersect. So it looks like if we cut off somewhere in here and then most of the back of that, we'd probably be all right. Actually, if we just take this curve and duplicate it, that'll give us kind of a reference point. Something like that. And something like that. So somewhere between here and here, we need to cut that out. So if I take this and I make a surface that goes halfway, and then I take this and I explode it, and I take this, and I'm going to use the C-plane waffle holding down the control key, and I'm going to extrude that, something like that. That gives us about where our cut needs to be, and I'm going to stick this on this side, and then I'm going to snap this to the center. And so this and this is vaguely where we want our cut to be. And here's a fun trick. I want to extend this surface. I'm going to double click the gumball to get it to spin, and I'm going to snap it down here, and then I'm just going to extrude it out a little farther. All right, and so if I take this and I just do this, holding down extrude, what I'm going to do is make a little cutter. So if I trim this and that, and then I grab this edge and I snap it to the edge of that, I can trim this, join, cap. Boy, there's a lot of thinking this early in the morning. And that gives me a little cutter that I can use in this guy. And we'll see whether this actually works or not. All right, so let's Boolean subtract that out from that guy. And I'm going to hide this for the time being. And then this guy, it looks like we missed a little bit on the angle, but we can get that later. Looks like we need to cut a little bit of this off too, so that's fine. So let's duplicate that. Hold down Alt, drag, and you get a curve. Like that. So that'll give us a little reference on what we need to chew off on that. So let's do that, and then we probably need to cut off, I don't know, let's just call it from like here to here. So these two curves we need to cut off. Now, cool thing about this is because this curve is on this surface, watch this. Push pull. Neat. Gone. And then if I take this curve and I stick it here and I move this to here, it's now on that surface. Push pull. Gone. We love push pull. All right, so those now fit together and have some sort of range of motion. Now, the question is, if I hide this guy and I mirror this, and it looks like that would work, but it's backwards, right? So we actually need to now mirror this way, and then align this. Man, I didn't think this was going to require so much thinking. Align it this way. And we have some intersecting parts, and it looks like we need a little bit of clearance. Actually, that's closed, so when it opens, this guy needs some clearance as well. So if we copy, paste, go to the front view, rotate between this point and this point. So then I got to figure out like how much of this guy to chew off. And if I grab this curve, hold down Alt, and then drag, I get a curve. Grab this guy. There's probably an easier way to do this that I'm not grokking this early in the morning, but push-pull, knock that off. Rotate between here and here. And we'll put that back where we found it. All right, that gives us our kind of range of motion in there. I'm going to call that good for this amount of engineering for this early in the morning. All right, so now we just got to do our detailing. And in this case, I'm going to inset. I'm going to hide all this. Actually, I'm going to delete all that. And it looks like I am not exactly aligned here, so let's fix that. So if I set my gumball to the center of this guy, and then I snap that to the center of that guy, that'll put it back. And I think we're mostly good. Maybe got a little hacking we need to do here. So let's push-pull this surface now, and I'm going to do the direction is going to be, actually, we're going to push-pull this, and we're going to do direction, and we're going to go in this direction like that. And we're going to just push this up just a hair. Give ourselves a little bit of clearance there. And it looks like that one's clashing just a bit, so we're going to just push-pull that. We're going to go in. Stop it. Stop it. I'm going to go in this direction. I'm going to go just a little bit. And then this. Knock that off. All right, so now let's inset. And it's going to remember what our last value was. And we'll push-pull this in to get our little detail there. And then we're going to inset back here. And then we're going to push-pull that. It's going to remember the value that we had before. So that gives us our detailing, right? And then we need to build some kind of pivot or something like that in there. And maybe there's no label on this side. And so maybe what we do is get rid of this and just trim it. Maybe there's no label there. Maybe this is where the pivot is. And we'll figure out where the pivot is just by drawing a line from this point. Actually, we'll put a point between this point in this point. So that's our center point. And we'll put a little pivot here. And we'll Boolean that together. Actually, I'm going to copy paste, and I'm going to make one that's just a hair bigger, and then hide it. And then I'm going to Boolean this one. Bring everything back. And it looks like that's sticking through, so let's push, pull, and bring this in a little bit, and then push, pull, and stick that one back. And then this is the, let's see, I grabbed the wrong one. So that is the inside of the pivot. So we're going to subtract that from that. And then bring that guy back. Looks like I pushed the wrong one last time. So that's our little pivot stitch. And we'll say that there's some kind of clever, it's either got a screw in it or something that holds that two together. And let's worry about the last little final details in here. And the one, and I'm going to rotate this back now that we've got a pivot point. I'm going to rotate this back to where it was for the drawing. Like that. And then we can finish out the rest of our detailing. And in this case, there's a little detail on the inside of this that allows that fastens the metal part. So if I project a line there and a line there, what that's going to do is that's going to put two lines on the surface that then are going to allow me to be able to push-pull that little detail out. And in this case, I only need the back one, so I'm going to do that, and then I'm going to draw another line, auto C-plane, stick it there. I'm going to draw another line here to here, and then I'm going to just push-pull. This to there, knock that off. And that gives me that little detail where that guy lives. And the shape's not quite right, so let's fix that. So let's push-pull this, and let's drag it out a little bit more. And then let's Control-Shift-Drag this and drag that up. And then let's drag a line from here to here. And then we'll just, went into outer space there for a second. And then we'll drag a line from here to here, just to clip that edge off. And we'll just go wing. Cap that, we're good. Okay, so there's that. And then our little metal piece, I'm going to do that with, let's do that with a 3-point arc. So I'm going to start here and there, go something like that, and it looks like it's a little smaller radius. And I'm just going to extrude that shape up like that. Stick it inside there. Drag to extrude for my thickness. And then it looks like It slides in and out of that part over there. But let's get it centered here. There's the mid. It slides in and out of that piece. So we need to copy paste, make this a little bit bigger, and then Boolean subtract that, and then Boolean there. So that slides in and out now. And then we've got one last little piece that looks like it hooks to the back one. So let's isolate that. And then there is a little plate. Actually, it looks like it's the other one. It's this one. There's a little plate with holds a pin. Let's call that. That's a good question, which one it belongs to. Let's call it this one. Let's do that. Let's see. Somebody said, what happens if you do different layers? I often, if I'm working on something really complicated, I'll do layers. For something like this, I don't really worry a whole lot about layers. It's always easy to break the model up later. So if I need layers, I'll do them later. But, as always, you do you. Whatever works for you is the right answer. Auto seaplane, so I can draw a circle right on this surface. And once we get that in the right spot, we can scale it. And because it's on the surface, that gives us the opportunity to push-pull. So we're just going to pull that out. And inevitably what happens when I do a product like this is I'll print one and then realize how far I've screwed up all the pivots and all that stuff. And I have to go back and sort all that out. But for the demo, we're going to assume it's all just done brilliantly perfect. The internet's going to have different opinions on that, but that's fine. Non-civil discourse is what makes the internet a beautiful thing. All right, so we're going to take this, and let's bring our part back. Do you see what I did with that? I just drew a curve, and then I just extruded it to get that ribbon surface. So then we're going to stick this in here, and this is going to go kind of all the way through because it actually has a hole in it. And it's centered on this thing. I find that isolate, for me, is faster than layers. Having to go from one layer to another layer to another layer to another layer. I find that isolate is just really fast. And so what I end up doing is I'll work on a part and then isolate it and then work on a different part and then bring that part back and, all that kind of stuff. So, and this trigger, and it looks like this is completely on the wrong side of where that thing needs to be. It actually needed to be on the back one. Oh, well. Let's get it out of there. Let's put it where it needs to be. Somebody probably watching this screaming, it's on the wrong side, it's on the wrong side. There we go. And we'll just untrim this. And then this actually now doesn't fit. So the trigger, let's draw a curve on this surface. Auto seaplane lets us do that. I'm going to just draw a curve from here to here. And then we can push-pull. Something like that. And that clear-ish. Clear-ish. And then we just need to figure out how to connect this to this. And that can be as simple as we do something like this. And then we join these together. Oh, you're going to like this. Watch this. Join, cap, merge all coplanar faces. Bing. Remade that piece. Then we can take this, because it overlaps that guy now, stick that in there, and then that kind of does its thing. And there's a spring in here. I'm not going to worry about the spring at this point, but if you want to put a spring in there, you could. All right, let's make this guy just a little bit more interesting with Inset. And I'm going to do this as a through point, and we're going to just add an additional little detail in here with push-pull, just because it looks cooler. And the nice thing about Inset is it remembers your last value, so does push-pull. So if I run Inset again and then just right-click, it gives me the same Inset. If I run push-pull again and I click and I drag in or out, if I go in, it's red. And then I just right-click. I don't left-click to set it. I just right-click. It'll give me the last one I did. So Inset, push-pull, like that. And then we can start playing around with, like, do we want to fillet stuff and all that kind of stuff? Or we can cheat and we can apply edge softening in the render mesh. All right, let's say these are a different color plastic. Like that. Let's call this trigger a metal, but it's going to be something dark. And it's going to be kind of rough. Something like that. And then same thing with this guy. Because this part is booleaned into the other part, I'm going to do a sub-object selection. So I'm going to Control-Shift-Drag and select all those pieces and then do a sub-object material assignment. So this is all still joined together, but I can assign materials by object. I really hate that orange. I'm going to do that a different color. There we go. That looks a little more fancy. And if we wanted to add a decal on here or something, we could. I didn't design one, so. Now, one cool trick that we can play is these surfaces in here could get a copy of this material. So let's duplicate it. And let's add a bump texture. Let's do like a crosshatch. And then let's sub-object assign these. And might be that we need to do our scale might be interesting. Let me change the color on this to make sure that it's actually doing what we want it to do. So that is the right color. And I'm in rendered. I'm starting to see it. It's not appearing enough. So what I'm going to do is actually I'm going to change this from a plastic to a physically based. When I change that from a physically based, I get more access to the actual details of the material, and I'm going to crank the bump up quite a bit. So now you can actually see it. And then I'm going to change the base color roughness, we're going to turn that up a little bit. And let's go into the actual texture itself. And let's crank its size up a little bit, not that much. There we go. Now that's starting to show. All right, now we can assign it to the other side. The defaults, sometimes the texture defaults, they'll work for a lot of stuff, but not everything. And so a lot of times what you end up doing is changing them to a physically based and then messing with the materials themselves. All right, I'm going to delete all my stuff. And then the last thing I want to do is in the properties panel, there's an edge softening value in here. And I'm going to turn edge softening on. And I'm going to change the softening radius to like 0.08, 0.04, something like that. And what it's going to do, let's force it, is it's going to actually apply a little fillet to everything in the model, and that's actually too big. Let's do 0.02. And so then when you render it, what you end up with is you end up with a little bit softer edges, so you get those highlights on the edges, but that's not actually real geometry. It's faked, so it's just in the render mesh, so that when you render it, you end up with, if we go into ray trace, you end up with these little edges in here, which look a little bit nicer if you ignore the little snot down there. But generally speaking, it's an easy way to add some additional texture or additional interest to your model without having to go ahead and model it. And it looks like that ray trace texture, or that texture, is a little crazy now. Interesting. It's actually painting the texture. That looks like a bug. Let's shut the rendering. Let's shut the image off. Actually, I don't hate that in black. What if we did those in black? Let's make this problem go away. Badoo! So much better. Ta-da! Fixed it. It's not a bug, it's a feature. All right, so that's that. And then if we wanted to add a decal or something like that in there, we could. I didn't design one, but you can certainly do that. And this plastic is kind of hitting a little hot, and so I think what I'm going to do is go to the HSV, and I'm going to turn the saturation or the value down a little bit on it. It's starting to get a little hot on the insides there. That looks a little better. And then we could light this thing, do whatever we wanted to it, but let's throw a different environment in here. I think this just has studio. I like the V8, the V8 automotive environment. This one, this Auto Studio, is kind of nice. Something like that. Maybe we want a floor, maybe we don't. We definitely want to get rid of that point. And maybe it makes more sense for this thing to be laying down, so let's go to rendered mode, and let's do something like that. It's actually more interesting on the other side, so let's roll it over. And then maybe it makes sense to have another one kind of laid jauntily in here. rotate it from here. And we compose our shot, and I like to change the camera from 50 to 35. It gives a little bit more drama to the scene, and then we'll ray trace that. That's not terrible for an hour and 17 minutes. Any questions with that so far? We can even have some fun and put some depth of field on here. And we'll set the focal distance to maybe this point and let it blur. Let's do, I don't know, 32. Blur the back out. Let's go smaller. Let's go like 12. Okay, cool stuff. All right, last thing, I have an NVIDIA card, so I have the NVIDIA denoiser turned on, and so it cleans up real quick. So actually after 15 seconds, this is cleaned up enough that if I stopped it and did a screenshot, this would be ready to go. Oh, good question. When I 3D print and it has soft edges, does it do them? No, unless you use a command called extract render mesh. And if you use extract render mesh, what it does is it actually takes the render mesh that has the softening on it, and it extracts that render mesh into a real mesh that you can then take and print. Things to keep in mind: if in our case, we forced the softening and it made some messy little edges here and there, that is something to keep in mind, because if it's got messy edges in the render mesh here, it'll have messy edges in the actual mesh that you extract. So let me show you a trick for that. So I'm going to just capture this to a file. So I'm going to save this for the rendering for the video later. And I'm going to just capture that, and we're just going to throw this on the desktop. We're going to call this clamp video. And so here's a cool trick. So if we go back to shaded mode, and I'm going to go back a little bit and put this thing back upright so we can see what's going on. So there's a command in Rhino 8 called shrinkwrap. And if we were going to print these parts, and I'm going to do it on, I'll do it on one of them because it'll go quicker. But notice, and let's shut softening off. I'm glad you asked that. That's actually a great question. So let's shut this off. So notice the sharpness here. And if I go to rendered view, you can see how laser sharpy that is. If we take this and we shrink wrap this and we preview it, don't need to fill holes, and we hide the input object, and we start cutting this in half until it gets, oh, interesting. Is this open somewhere? Oh, it's open. Let's fix that. There we go. Still open. Where are you open? Ah, there's a little micro edge down there. There's a command called fix remove all naked micro edges. No, I got rid of that. Now it's a closed poly surface. All right, so now let's shrink wrap this. That's better. Now if we go 0.03, we don't draw the mesh wires. Actually, maybe we do draw the mesh wires, but we look at it in rendered mode. There we go, 0.15. Notice what's happening is this thing is starting to get tighter, right? But also, if I put a smoothing operation on it, say I said put 10, what it's going to do is it's going to smooth over those edges, and I'm going to get real fillets. The more smoothing operations I put on, the softer it's going to get. This is a real mesh. This is something that you can print. Now there's a cool trick that you can pull. You can actually, and if I just finish this, you can apply, instead of a bump map for this grip, you can apply a displacement, which displaces the render mesh. You can extract the render mesh without softening and then shrink wrap the render mesh and end up getting a beautiful soft part that has beautiful soft edges like this. And this will print absolutely wonderfully. So shrink wrap is a really cool trick if you just need like an overall softness. See that? Now, if you need sharp stuff like here, you'll want to shrink wrap this first and then Boolean this later with a mesh Boolean. And that way you can get a sharp or soft depending on when you shrink wrap and then what you do after it. But if you notice the difference between the part, if I hide these edges, you can see the difference between these two. That looks like a plastic injection molded part. This looks like something that still needs a bunch of filleting done to it. So cool trick for getting there quick. I use this all the time if I just need to just knock the edges off of everything. And like I said, if you need sharpness in other places, save some cutters. So I would save a cutter that would make this hole. I'd probably save a cutter that makes this edge down here. Shrink wrap the part first and then do a mesh Boolean later, and then you get a really sharp edge with the softness everywhere else. Okay. Cool stuff. Thanks for asking that question. That was a great question. All right. Anything else I can help you with? If not, I'll let you go. Fabulous. Thank you for sticking with me. Thanks for watching. My name's Kyle Houchins, Techno-Trainer for McNeil. This is Getting Started Rhino 8 for Windows. Go make great stuff. Have a great day.